Electricity is so much a part of our everyday lives, it's easy to forget how dangerous it can be.
It's invisible, inaudible, almost undetectable. The only way we can sense it is by feeling it. And once you can do that, it's way too late to take action in a safe way. When working in, on, or around electricity, there are three primary hazards everyone should be aware of: electrical shock, arc flash, and arc blast. In this section, we are going to talk about electrical shock.
So, you know what an electrical shock is, but what's actually happening to your body when you get shocked?
After you come into contact with something electrified, current passes through your skin and tissues, and that causes an electrical burn. Those burns cause internal and external damage. The higher number of amps that passes through your body, the more severe the injury.
Even just a small amount of current can have a devastating effect on the human body. At just 1 milliamp, you'll notice the current flow. At 5 milliamps, you'll reach the let go threshold. That's where your muscles contract, and you might not be able to let go to break the circuit. At 50 milliamps, you'll feel severe pain, muscle contraction, and respiratory paralysis, and that can result in death. At 1 amp, the current can cause ventricular fibrillation or irregular heart rhythms. If the current passes through the heart, death is likely. And at 10 amps, severe burns and cardiac arrest occur. That's almost always deadly.
To put that all in perspective, just think that a normal toaster draws about 9 amps.
So, how many amps does a shock victim experience? We can use Ohm's law to figure it out.
To calculate the amount of current flowing through an object, we divide voltage by resistance. Let's start with a common phase-to-phase voltage in your facility, 480 volts. Resistance is a little tougher because there are a lot of variables, including both the individual and the environment. Moisture, even sweat, can decrease the resistance of the human body. Plus, if your body comes into contact with a circuit, the current breaks through the skin quickly, further reducing the resistance. Let's plug 1,000 ohms of resistance into our formula.
All right, let's divide 480 volts by 1,000 ohms of resistance. That gives us almost 500 milliamps. 10 times the amount of current it takes to cause a fatality.
Did you know that most electrical fatalities in the United States happen at a voltage level below that? Do you know what it is? Only 120 volts. If we rework our example, dividing 120 volts by 1,000 ohms of resistance, we end up with 120 milliamps, more than double what can be deadly.
So, we know current is a major factor. But what else determines the severity of an electrical shock? Time. The longer you're part of the circuit, the more damage it will do.
This graph represents a current's effect over time on a human body. The current enters through the left hand and exits through the feet. Using the 500 milliamps from our example, you can see that after just 1 second of connection, the likelihood of heart fibrillation increases from just 5% to over 50%.
Remember, it only takes 5 milliamps before you can't voluntarily let go. If you're working on 480 volts and become part of a circuit, you're almost 100 times over the let go threshold. We've been using 1,000 ohms of resistance in our example, but again, resistance will decrease rapidly once current breaks the skin. In almost no time, the current will cause your muscles to contract, leaving you locked in the circuit until help arrives.
You might be thinking you'll be safe because you have circuit protection, but keep in mind the smallest breaker in most facilities is 20 to 30 amps. In our example, the circuit will never even detect an issue and the device won't interrupt the fault. This is especially true when we have a completed circuit between two phases or when a circuit isn't designed with adequate ground fault protection.
That takes us to the final factor that determines the severity of electrical shock: path. What we mean by this is the path the current follows through your body. To keep it simple, the industry has identified two pathways: step potential and touch potential.
Step potential is when the current enters through one foot and passes out the other. Oftentimes, we'll see this around high voltage overhead lines when equipment comes into contact with an energized line that then energizes the ground. If you're not a qualified individual, it's critical to maintain a safe distance of at least 20 feet from equipment working near overhead lines. If you find yourself in a situation where you need to exit an area with step potential danger, put your feet together and hop to safety.
Touch potential covers every pathway that's not foot to foot. So it's a lot more common, especially inside industrial facilities. Many times, current enters through one hand and will exit another part of the body that's in contact with a grounded frame or other energized conductor. This could be your other hand, shoulder, head, chest, or legs.
Now you might be thinking, what are the chances that I get shocked?
There are a lot of factors, and you need to be aware of all of them to be as safe as possible.
First, let's talk about voltage level and proximity. Different voltage ratings have different requirements for clearance. The greater the voltage, the greater distance you need to stay back in order to remain safe. For example, for this 240 volt panel, the restricted approach is avoid contact, and limited approach is 3 feet 6 inches. For this 480 volt MCC bucket, the restricted approach is 1 foot, and a limited approach is 3 feet 6 inches. For this 4160 medium voltage starter cabinet, the restricted approach is 2 feet 2 inches, and the limited approach is 5 feet. And for this overhead movable 13/8 system, make sure to leave at least 10 feet of clearance. Note that higher voltages may need even greater safe clearance distances.
Remember that the limited approach boundary is the boundary where exposed energized circuits pose a shock hazard. Unqualified individuals should never cross this boundary unless they're made aware of the hazards and continuously escorted by a qualified individual. The restricted approach boundary is the distance at which an increased likelihood of electrical shock exists. It should only be entered by qualified personnel using the proper shock PPE.
Approach boundary recognition is critical because electricity can travel through air. That means you don't need to come into direct contact with an energized circuit to receive a life-threatening shock. We're very grateful to have our friend to share what he's learned after surviving an accident with electrical shock boundaries.
Hi, this is Phil from EPSCO, and I'm here with Mark today. Mark was involved in an incident some time ago, and Mark was kind enough to spend some time with us today to talk about his situation and to share with us some of his pointers and some of the things he learned along the way.
You're welcome, yeah.
So how did you get into electrical?
Electronics is, you know, in the mid-60s, electronics was the big new thing. Mm-hmm. So I went to Brown Institute. Okay. I went through electronics first.
Yep.
So they got a bunch of us coming through electronics school, mm-hmm. They offered us jobs to go into electricity. So
right.
then they sent us through an apprenticeship program.
Okay.
And we were hired to fix this automated equipment. That was the base, so that was my start. So.
Yeah. And that was in the 60s.
That was in
late 60s, early 70s.
Well, it would be the turn of the 70s.
Right.
Yeah, began late 60s, early 70s.
Yeah. So back in those days when you were working in that environment, what would you think the safety culture was?
You know, safety was always talked about, always preached. But the actual practice kind of really fell back to the individual. It was all the safety was available to programs and information, and was all available. But it seems to me a lot of it fell onto the individual.
Okay. So if you look back at your situation, the incident you were involved in, what was leading up to that? Can you walk us through kind of what was happening there, kind of leading up to how that incident occurred, and what was kind of the physical,
well,
what happened there? What happened to you personally?
The background to it was we were PMing the input switches to the facility, the primary switchgear, and with that it was a 13/8 system, and over time insulators break down, and knife blade switches needed lubing and cleaning, and we were in the process of doing that, with that it was on a 4th of July weekend, and we could shut down the facility. So we were kind of under the gun with a time frame, and it was a misty day. It was water in the air, and so we're with a time frame. We're trying to decide, shouldn't we? Electricity and water don't mix. But we had a break, and we thought we'd at least get one set done, one set of switches. So we had them all securely shut down, locked out, tag out, ground clusters. We had them very secure, and I was inside doing one, and with the pressure, with the time frame, we were in a hurry. So I come out, and the next switch was open. And obviously, I in my mind, I helped open them up, locked out, put ground clusters on, locked them out. In my mind, it was safe, so I started heading into that. And what happened? Another fellow came on the job site and opened a hot switch we weren't prepared for, that's what happened to me. So
yeah. So that switch was energized.
That switch was energized,
opened up.
Yes.
And you're a guy working in there at 30 years experience?
Yes.
Or more.
30, probably 30, yeah,
Yep.
yeah, or more, yeah.
So you got 30 years of experience, you're working on it, and you get out of that one switch, and you look over there and say, this is ready to go.
I helped shut them down.
Right.
So I in my mind, I knew it was safe.
Yep.
And
yeah. So then what happened? You walked into it, climbed into it?
No, these switches, it's a pretty good sized box. It's probably about 6 feet tall, 30 inches wide, and about 4 feet deep. But and the back is a great big bolted on cover. So to do that, you take off this cover, and it's got, so you step over to get in.
Okay.
And I was in the process of going in. I had, I had my hand on the edge of the switch. I was stepping over this base plate, and reaching, so you're just heading in, and it jumped.
To you.
It jumped to me.
Yep.
And and I'm sure because of the humidity, and how close I was to the hole.
Right.
Yeah.
So you had one hand grounded,
other hand
going into it.
You're kind of stepping in, right? You're
momentum.
guiding.
Yeah.
You're balancing. So it jumped to my hand.
Yeah.
And it came out to my other hand.
Right.
Yeah.
Then what do you remember? Do you remember doing that? Do you remember stepping into it?
I don't. But I only know because how you do that. And I don't remember it jumping at me. I guess I remember entering.
Okay.
But the next thing I know, I don't. They say there was a pretty loud explosion. I don't recall hearing that, but I remember looking. I was laying spread eagle out on my back on the ground, so it blew me out of the switch. But my heel caught the base plate and tipped me over.
Oh.
And so here I was spread eagle,
right.
And you can't move. Now you're paralyzed. You can't move. And I was looking up at the sky, and yeah, I couldn't move, and everything was kind of a greenish. I had no color, just pea green. And the first thing, you don't move, is the first thing you think about, well, I'm dead. I'll just wait till the lights go out.
Right.
And honestly, I was laying there spread eagle, well, I'm dead now. And then about 30 seconds later, I said, wow, I must be alive.
Wow.
Yeah. And then probably a minute or so later, it starts to hurt. The pain comes, and it comes at you pretty strong.
Yeah. So were you on fire at this point?
No. Actually, we didn't have electrical gloves. We had chemical, because we had solvents.
You were cleaning.
We were cleaning, so we had a cleaning solvent or a solution.
Right.
I don't know if it was a solvent, but so we had latex gloves on.
Right.
Rather than electrical, insulating gloves.
Yep.
And it melted the glove onto my hand.
Oh my.
And yeah, that's what.
So then the people that were in that area, how did they respond to it? What was do you have any, did they ever tell you what they did when you were?
I don't recall that. I don't remember them getting there, but I remember they had me on a gurney and they're starting to cut my clothes off. They're looking for exit wounds.
Right.
And I don't remember anything then until we got to the hospital.
Right. Did you you found the exit wounds then?
Yeah, it was my hand.
The hand that was grounded.
Yeah.
Right.
The rest of me, they never found. There was no other exit wounds, just my hand.
Wow.
So just my hands were affected.
Yeah. So from now, what effect has that had? Just, I mean, granted, it's been almost 10 years, probably, or more, whatever it's been. What lasting effect do you have from that injury?
I think just limited. I have muscle strength, muscle loss.
Yep.
Strength and dexterity. I can't keyboard and those kinds of things.
Oh.
But strength. I probably have half the strength I used to.
Okay.
Like a gripping strength.
Yep.
But other than that. I kind of, you just get,
normal
you kind of get, you get used to your limitations.
Sure. Yep.
Actually, I'll tell you, a screwdriver, the exit wound, if you're pushing on a screwdriver, right in here, that's still painful. It's
still
scar tissue.
Wow.
Well, yeah. It's
So when you kind of got through, how long were you in the hospital?
A month.
A month.
Yeah.
When you came out of that,
I don't remember days, but it was a month.
Yeah. So when you got home from the hospital, how long do you think it was? You went back to work, didn't you?
I did, but I had I don't know exactly, but I had probably 3-4 months recovery time.
Sure.
Because I kind of was working on it to get discharged early, and they let me go, promising that I'd be back every day for dressing change.
Oh, sure.
So I had
from the hospital.
I had to go to the hospital every day for dressing change for probably 2-3 more weeks.
Right. Wow.
And then physical therapy. Actually, I had physical therapy for probably at least a year after that.
Yeah.
Trying to gain strength and trying to those recondition.
So now you kind of fast forward a bunch of years. All of us get more gray hair. Do we get smarter? Do we get wiser? People look at now you're more aged than you were there. If you've had obviously a long time to reflect on that. Is there a message that you would say if you met a young person somewhere or somebody that you had an opportunity to have a meaningful conversation with? What would that be? What's that look like?
Well, I think my message would be safety is in everybody's your own personal interest. I think even victims have some responsibility or some in an accident. I'm searching for words, but safety. You have to take ownership of safety as well. It's not somebody else just preaching safety at you. You need to live it. You need to work it.
Yep.
You need to be conscious of you. You want,
Yeah.
and you do have to take ownership of your own safety as well.
Yeah.
You can have all the safety programs you want, but you have to live it.
Right.
Even for me, if I would have taken just 10 seconds to look around and see that everything was in order, see if things are normal. And if you're working a project, you know what should be normal and what isn't. But it doesn't take but just a few seconds to look around and reestablish that things are safe. It's in all our best interest.
Right. So we get pushed and pushed and pushed. Everybody wants it more, faster. And in some of those situations, we owe it to ourselves to take the time and just say, hey, let's just relax. It's not going to take that much longer. It's going to be okay. Let's make sure we got this nailed down.
Yeah, and 10 seconds isn't a very long time.
No, not at all.
Just to look around and establish things are what they should be. And for me, that's where I should have had some ownership doing that.
Right.
And it certainly could have been avoided.
Yeah.
10 seconds.
Interesting. Very interesting.
Or not even.
Right.
So, and any project has 10 seconds worth of time.
Yeah.
With everything involved, I think there's always time for everything but an accident.
Yeah.
So,
yeah.
So you were asking me the ramifications of the future and actually you can kind of see how devastating it is. It's skin graft all the way up my wrist and the whole back of my hand across here and down my fingers, and when they do the skin grafting, they keep it together, put the skin over, and then they cut it and staple it, and all those little dots they put it through a tenderizer.
Right.
It's because when you cut skin apart, it just shrinks up. So they put it through it creates, puts all those holes so they can stretch it out. So
they have to teach the skin how to stretch it.
Yeah. And so actually, little fingers always take a beating.
Oh,
and I asked
right.
and plastic surgeons are responsible for burns now. And I know my plastic surgeon personally, and I run into him once in a while. And so I asked him, well, George is his name, his first name. I said, George, my little finger still doesn't work. And he just says, well, lots of little fingers don't work. But because he does burns. He was the head surgeon in the burn unit at HCMC down in Minneapolis. And so I said, yeah, we have lots of little fingers that don't work.
Right. You can see is that the webbing from where the
No, that's where they perforate it.
Oh, that's perforated intentionally that way, just to give it some flexibility.
Yeah. And
that's amazing.
Here's where they got the skin.
Wow, right.
So it's wraps all the way around, all the way up to my hip.
Yeah. I'm really glad you took the opportunity to just share such an amazing story with us. But I tell you what, there's a message that you have that other people in the trade, I think, really are going to gravitate toward, and I think you really should grasp a hold of. Just simply because that 15 seconds is all it takes.
Yeah.
And that message of just taking your time and just stopping. Let's think this through. Does everything look right?
Right. It doesn't. It doesn't impinge on the job at all.
Right.
Just a brief review before you go on. Just a little bit.
Yeah.
Yeah.
Yeah. That's an awesome message. Thank you.
Okay. You're welcome.
Well, Mark, I really want to thank you for taking some time with us today. And I really appreciate your message, and hopefully we can share with as many people as we can. We're going to have an impact with it. Thank you.
You're welcome, yeah.
Now, let's talk about how the job you're doing and the equipment you're working with can factor into electrical shock. Be aware that older equipment might not have the safety features you're used to with modern equipment. And with any equipment, you should perform complicated tasks like installation and maintenance in a de-energized state, unless properly justified to be performed while energized.
Now, what's the most influential factor affecting the chance of an electrical shock? You guessed it, the presence of power. No amount of experience or caution compares to the effectiveness of removing power from a circuit and putting it in an electrically safe work condition.
No matter what you're doing, there is almost no scenario when working around energized voltage is acceptable. Whether that's troubleshooting, maintaining production, or anything else.
Always create an electrically safe work condition first. And if working on energized equipment, wear your PPE and use insulated tools.
You might have gotten a shock around the house or at work and it didn't seem like a big deal. But having walked away from a shock before is what makes electrical shock all the more dangerous. Because it's just pure luck.
Next time, you might not be so lucky. The current flow could be stronger, and you can't predict when current will take a lethal path. It's important to report any incident or injury as soon as it happens. If you accidentally become part of an energized circuit, you might feel nothing is wrong at first, but just like when you burn yourself on a hot stove, an electrical burn can worsen over time. So if you have any kind of electrical accident, seek medical attention right away.
That wraps up our section on hazards and risks of electrical shock. Think back to our examples and always remember, serious injuries or fatalities can occur with even a small amount of current flow.
To keep your work environment as safe as possible, observe shock protection boundaries, de-energize whenever possible, and make sure to wear your PPE.
Next up, we'll discuss arc flash and arc blast. See you soon.